This is the second video for section 1.3. So we're going to do an example of using the limit definition to calculate the derivative at a point. Let's let our function f of x be negative 7x squared plus 1. So what I'd like to do is use the limit definition of the derivative to calculate f prime of negative 1. And I'd also like to describe what f prime of negative 1 means geometrically. So let's start with f prime of negative 1. Now, by definition, that is the limit as h goes to 0 of f of negative 1 plus h minus f of negative 1 all over h. And now I will substitute in what f of negative 1 plus h and f of negative 1 are. So we have the limit as h goes to 0 of negative 7 times 1 plus h squared plus 1 minus negative 7 times negative 1 squared plus 1 all over h. I will FOIL out that 1 plus h squared and have negative 7 times 1 plus 2h plus h squared plus 1 minus a minus 6. So negative 7 times 1 plus 1 is my negative 6. This is all over h. And now if I simplify a little bit, distribute that negative 7 through, I get negative 7 minus 14h minus 7h squared plus 1 plus 6 all over h. And of course that negative 7 plus 1 plus 6, those all sum to 0. And I am left with the limit as h goes to 0 of negative 7h squared plus 14h all over h. So I will factor out an h from the numerator, and then I will do a careful cancel. I can cancel those h values because h is not 0 since I'm taking the limit as h goes to 0. So h gets small, but it's never 0, so that canceling is valid. And then I'm left with the limit as h goes to 0 of negative 7h plus 14. Now, substituting in h equals 0 is a valid move for calculating this limit, and so I will do just that. So I get negative 7 times 0 plus 14, which equals 14. So my conclusion is that f prime of negative 1 is equal to 14. In other words, the derivative of f at the point negative 1 equals 14. And geometrically, what does this mean? It means that the slope of the tangent line to f of x at x equals negative 1 is equal to 14. And that's really important. So make sure you stick that in your brain. And let's just sort of convince ourselves that at least that is somewhat reasonable given the confines of my slightly inadequate drawing. So f of x equals negative 7x squared plus 1 is a parabola that faces down and is shifted vertically 1. And what we're calculating is the derivative at negative 1. So that means we want to look at the slope of the tangent line to f of x at x equals negative 1. So I'll draw that tangent line in there, and certainly the slope is positive, and it seems to be fairly steep. So it's reasonable to guess that or it's at least not unreasonable that the slope of the tangent line is equal to 14. And of course, if you use some software to draw this graph, you would get a more accurate depiction of the tangent line and of its slope. But at least it's it does not contradict what we just calculated. So for your exercise, I would like you to let f of x equal x squared and use the limit definition to find f prime of 3, and you should also describe what that means geometrically.